Hello, I will show you how to make a simulation using Chandra Air. The animation I use is an animation found in the site Mixamo, which allow to download very good animations. Okay, I go to the beginning of the animation. I start BWD and it is for the demonstration I will restore all the default parameters. It is the best way. For importing this air, I will use spring reduction, and I import the collision object as Tresne. Okay. Now I will import Chandra air as air, naturally, and I will use a specific rigidification at the beginning for all the air. I make a small zoom. Okay. I will use a stretch with a very low value. These two parameters allows to create a small rigidification for each vertices. And I will create a rigidification by neighborhood, but a rigidification on a very small distance and with a very soft value. This allows to create a small rigidification on the strands of the air. I put the distance to 0.1 and I create a very soft rigidification by setting a value to 1. Okay. Now I will generate the first springs. They are imported. The first rigidification is made. Okay. Now I will define the vertices which will be used to tie the air on the head of the character. I use Genesis 3 for that. I go to see the character has been imported as a high level of resolution. To simplify the selection, I used the Genesis 3 for DAS as a base resolution, but it is easy to extend this selection using a simple extension. Okay, Go back. Here is the selection with a simple extension. It is the right one. Then I show the air vertices on the head, but these air are not enough. It is necessary to cover a great part of the head, on the top of the head. So I will increase this value, this distance. Making a test, value of 1.5 is very good. And I will make a zoom. I will keep the softness to 0.1, which is a soft enos value, but it is the right one. Go back. Okay. Now I can generate the springs. Okay. All is ready, but the air are very soft, too soft for the simulation. It is necessary to rigidify them. I will restore the selection using this. I make a zoom. The second memory. This allows to retrieve the selection made during the importation of the air. Then I will do a rigidification. First, I make a rigidification by neighborhood using the current distance. It is 0.5 for the air with strong enough softness, or strong enough stiffness. I set it at 0.01, and I select the mean distance, and I set it at the half value of the distance, 0.25. All is ready. I can start the rigidification. This rigidification is difficult enough to make because there are many vertices, and these vertices are very close. So there are many springs that are generated. Program first found the relation between the vertices, and then it generates the springs, sort the springs to keep only the different ones, and then it generates really the springs. The different values as a value defined with a very small rigidification at the beginning of this example is very can be very different on different air, because the structure of the air are generally very different, and it is not easy to define this value by default. The sort has been made, and now the springs are really created. This takes enough time to generate all these springs. I think the spring capture slow down the simulation and the work of the program. Okay. Now I will do a second rigidification. The air has been rigidified with a very soft rigidification at the beginning. Then the rigidification which has been made work only on the top of the head. Now it is necessary to rigidify all the strands in the bottom of the air. So to do so, I will keep the first selection. I inverse this selection, and then I will do a rigidification by extension on all this part. I create a rigidification using a I value 5, and I make a very stiff rigidification using a value at 0.01, and then I create this rigidification. The rigidification by extension is faster than the rigidification by neighborhood, because the structure of the mesh is known at the beginning. Okay. There are many springs are are worked only one time, because there is no duplicated springs. It is better to work with only one spring for between two vertices. Now all the work is to create the rigidification has been made. It is possible to start the rigidification, the simulation by the dynamic simulation. Okay, I can start it. I will decrease a bit the gravity to improve the simulation, but the gravity hey. I keep the simulation as it is. The simulation will take a long time to be created, so I will stop the recording, the simulation, and I will restart the recording just before the end of the simulation. The 31st frame has been used to create a transition between the T pose and the first frame of the animation. The real animation has not been started. Okay. I will stop the recording. I restart the recording of the simulation. The simulation finished. The parameters used for this simulation works correctly for Chandra air, but I want to make the same animation and simulation with sunny air, and I think the settings will be a bit different. Some parts of Chandra air at the back of the air are very big meshes, and the behavior of these parts are very different of very small strands. I will try to use the same settings for sunny air, but I will look at the results. Okay, the simulation is finished. It will be played. You can see some parts are composed of big meshes, but the behavior is correct. Move a bit on the top of the head. Perhaps it would be better to have a stiffness more efficient with a lower value. Okay. Now you can press on the button Send the animation to host to transfer the simulation to that 3D. Okay, but this is very long work, and it is a result you can see in the previous video. Okay, I hope this tutorial was useful to you with my my bad English. Okay, bye.